Dear students, after studying this module, you shall be able to know the need to define water quality in relation to its particular use, learn the terms water quality objectives, criteria and standards, and also you shall be able to identify the factors that influence prescription of water quality criteria. Let us start this topic now with the introduction. Water quality. Water, as you all know, is an essential component of life. Gets also degraded in quality when it contains an excess of unwanted chemicals and harmful microorganisms. Water gets polluted by various causes and sources. Water bodies have many uses such as municipal use, agricultural, industrial, fisheries, recreational use, etc. And the term quality must be considered relative to the intended use. There are many aspects of water pollution and there are many variables that determine water quality for a given use. Let us now take each of them separately. First is the biological. This includes microorganisms, cellular and microscopic bacteria. They contaminate both ground and surface water and cause various waterborne diseases like diarrhea, cholera, typhoid, etc. Second is the physical one. This includes the dissolved and suspended solids in the water bodies. Plants, leaves and degraded organic material, etc. become the part of suspended matter. Ions like nitrates, hydroxides and chlorides are completely soluble in water and are called dissolved solids. Now let us take up the chemical aspect. This includes the solubility, chemical reactivity, temperature, etc. and they play a very important role in the chemical quality of water. A high level of acidity or alkalinity, toxic elements and carcinogens, etc. degrade the water to a large extent. Now let us take an example. For example, we should take water for domestic use should be free from all types of suspended and dissolved impurities and also microorganisms. On the other hand, if you see, for swimming and boating purposes, the quality standards are less vigorous. Therefore, water quality is an issue that relates the chemical composition of water for particular use and societal needs. The three important factors that control the quality of water are the biological factor, the physical factor and the chemical factor. The physical, chemical and biological characteristics of water have a varied impact across different uses of water in different sectors. Now, let us come to the topic of water quality parameters. Water quality standards are assigned according to the goals for aquatic system by assigning its uses, managing to protect those uses and creating requirements such as anti-degradation policies to protect them from various pollutants. Set by each state, water quality standards regulate how clean a water body should be. States designate water bodies for specific uses based on their goals and expectations for their waters. Typically designated uses include: first is the protection and propagation of fish, shellfish and wildlife. Second is recreation purpose. Third is public water supply. Fourth is the agricultural, industrial, navigational and other purposes. The important parameters that are normally associated with the measurement of water quality in monitoring situations are turbidity, salinity, biological oxygen demand, also designated as BOD, chemical oxygen demand designated as COD, microbial count, bioaccumulation, hardness of water, total dissolved solids, that is TDS, etc. Some of the important parameters for water quality standards are given. Now let us discuss these parameters. First one is the hard and soft water. The presence of multivalent cations, most notably calcium and magnesium ions, are referred to as water hardness. Soap does not produce lather with hard water. Instead, it forms a very sticky and gummy deposit called scum or soap curd. On the other hand, soft water has moderately low or low levels of ions and is considered safe for drinking purposes. The table here gives the relative amount of total dissolved solids in different types of water. Now let us study this table. The classification and the amount of TDS in parts per million. In very soft water, it would be 0 to 70. In soft, it would be 70 to 140. In slightly hard water, the level is 140 to 210. And in moderately hard water, the level of the amount of total dissolved solids is 210 to 320. Then comes hard water. In this, the level is 320 to 530, and in very hard water it is greater than 530. Second is the biological oxygen demand. Biological or biochemical oxygen demand or BOD is known to be the standard amount of oxygen needed for biodegradation by microorganisms. Biochemical oxygen demand is said to be an indicator of the quantum of pollution load. If the load of pollution is high in amount, less will be the dissolved oxygen in water or greater amounts of dissolved oxygen shall be consumed. Similarly, a low value of BOD indicates relatively pure water. It is estimated that for drinking water, the BOD should be in the range of 0.75 to 1.5 ppm. Contamination to water caused by any specific chemical cannot be measured by biochemical oxygen demand. It is basically a measure of the contamination caused by totality of those compounds which can be oxidized in the presence of microorganisms. A large number of organic and inorganic compounds, however, are resistant to microbial oxidation. These therefore do not add to the BOD because they make water unfit for drinking purposes. Third, we will discuss the chemical oxygen demand or the COD. At times, biochemical oxygen demand does not give an accurate assessment of the pollution load in a water body. As has been stated earlier, some compounds like detergents, etc., are resistant to microbial degradation and hence they do not add to the biochemical oxygen demand. Some other pollutants like cellulose are slow to get oxidized. Thus, during the 5 days period required for the elucidation of the BOD, these may only be partially oxidized. Thus, whole contribution is not taken in the BOD or cannot be considered in the BOD. It is also probable that water sample in question may contain toxic compounds like biocides which may poison the microorganisms even before they can act on pollutants. Moreover, the 5 days period required to assess the water quality by BOD method is quite long. Although chemical oxygen demand or COD is a fast and reliable method for assessing the water quality, it suffers from the drawback that aromatic hydrocarbons or their derivatives are not easily oxidized by most chemical oxidizing agents, including potassium dichromate. Hence, their presence cannot be judged by chemical oxygen demand either. Now, the fourth one is DO. The Organic pollution load in water encourages the growth of myriad of microorganisms. These microorganisms decompose the complex organic compounds into simpler inorganic constituents like carbonates, bicarbonates, nitrates, sulfates and phosphates. The removal of hazardous organic compounds from water by microorganisms is called self-purification. The microorganisms which bring about self-purification consume oxygen dissolved in water by way of respiration. If the amount of dissolved oxygen is high, the degree of self-purification of water would also be high. In such cases, a milder water treatment operation shall be required. If, on the other hand, the amount of dissolved oxygen, that is the DO, is less, some of the impurities would not be eradicated by self-purification phenomena, and hence advanced water treatments would be necessary in such cases. Thus, the level of dissolved oxygen is the most valuable analytical measure of the condition of polluted water. There are many factors affecting the concentration of dissolved oxygen in a stream. This includes temperature, as oxygen is more easily dissolved in cold water, flow, as the concentration of oxygen varies with the volume and velocity of water flowing in the stream. Faster the flow of water, more will be the concentration of oxygen entering the water from the atmosphere. Fifth, we will consider bioaccumulation. The phenomenon of successive increase in concentration of the pollutants through a food web is called bioaccumulation or bioconcentration. For example, DDT, which is a non-biodegradable and a carcinogenic chemical, tends to undergo bioaccumulation in water bodies. Therefore, while formulating the water quality criteria, due concentration or the consideration is given for bioconcentration and persistence of DDT in that particular water stream or the water body. Now let us take the topic of water quality criteria and standards for various purposes. For proper functioning of any water body, it should be highly pure because drinking water should be of the highest purity. As water is very demanding, its management is very important for future security also. In order to set the standard for the desired quality of a water body, it is essential to identify the uses of water of that particular water body. Water quality standards are the basis of the water quality control program directed by the certain authorized agencies. A water quality standard is advanced to protect and maintain the quality of water necessary to meet its requirements such as swimming, recreation, public water supply and or aquatic life if present. Now the water quality standards, they consist of 4 basic elements. First one is the designated uses of the water body, that is whether it is for public water supply, aquatic life or the recreation. Second is the water quality criteria to protect designated uses by limiting chemical constituents that may be present in that water body. The criteria consists of numeric concentrations and or narrative requirements. Third one would be an anti-degradation policy in order to maintain and protect existing uses and high quality waters. Fourth is the general policies which address implementation issues like low flows, variances and mixing zones. Now students, having discussed this topic, we are moving on to the water quality criteria for classification of various water bodies as discussed in some forms before. In India, the Central Pollution Control Board, also designated as the CPCB, has developed a concept of designated best use. According to this, out of the several highest quality is termed as its designated best use. 5 designated best uses have been identified on this basis. This classification helps the water quality managers and planners to set water quality targets and design suitable restoration programs for various water bodies. And the next table, as you see here, it discusses the designated best uses of water, and the source is the Central Pollution Control Board. Now you can see here it is divided into the designated best use, the class and the criteria. Now let us discuss each one and each designated best use separately. First one would be the drinking water source without conventional treatment but after disinfection. This belongs to class A. Now let us discuss the criteria. First is the total coliforms organism, that is the MPN in 100 ml water shall be 50 or less. MPN is the most probable count. Second is the pH between 6.5 to 8.5, that is neutral to slightly, very slightly basic. Third is the dissolved oxygen, that is it would be 6 milligrams per liter or more. The fourth criteria in class A would be that the biochemical oxygen demand should be measured in 5 days and should be 20 C, that is at 20 degrees Celsius. It should be 20 milligrams per liter or less. Let us go to the next designated best use. It is the outdoor bathing which is organized. It falls into the class B and the criterions are total coliforms organism or the MPN should be 100 ml, in 100 ml shall be 500 or less. Second criteria is pH should be again between 6.5 and 8.5. Third is the dissolved oxygen should be 5 milligrams or more, and the BOD should be 3 milligrams or less in the same conditions, that is 5 days and 20 degrees Celsius temperature. Now let us come to the third designated best use, which is the drinking water source after conventional treatment and disinfection. This is the class C. The total coliforms, that is the MPN in 100 ml should be 5000 or less. pH should be between 6 to 9. Dissolved oxygen should be 5 milligrams per liter or more. The BOD should be 3 milligrams per liter or less. Now the fourth designated best use is the propagation of wildlife and fisheries. This falls in class D. For this the criteria is that the pH of the water body should be between 6.5 and 8.5. The DO, the dissolved oxygen, is 4 milligrams or more. There should be free ammonia as like the source of nitrogen. Fourth criteria is the biochemical oxygen demand in the same condition should be 2 milligram per liter or less. The fifth designated best use is the irrigation, industrial cooling and controlled water disposal. This falls in the class E and the criterion are the pH should be between 6 and 8.5, electrical conductivity at 25 degrees Celsius, micromoles per centimeter, maximum should be 2250. Sodium absorption ratio maximum should be 26 and the boron should be 2 milligrams per liter maximum. There are other classes which fall below the class E and not meeting any of the criteria which is stated for A to E classes. Let us now consider a term known as sodium absorption ratio or the SAR. It is a measure of suitability of water for use in agriculture irrigation as determined by concentration of solids dissolved in water. The formula for calculating sodium absorption ratio is SAR is equal to sodium ion concentration divided by square root of half brackets calcium plus magnesium concentrations. Now, after having studied the various criteria of water quality standards, etc., we shall now summarize this module. We have taught you in this module that water quality criteria are statements broadly defining the safety margins for the physical, chemical and biological characteristics and constituents of water. Water standards are prescribed by authorized agencies considering the type of use, quality criteria and also other features such as practical attainability, cost, local conditions, public need, etc. We told you that water quality standards are prepared based on criteria like health. All unknown sample data is compared to such standards. Drinking water has to have higher standards, whereas water for use by animals can have lower standards. Every country has evolved a set of water quality standards relevant to that region, whereas WHO has worked out globally suitable health-based water quality standards. The CPCB, that is the Central Pollution Control Board in India, has developed a method based on the concept of designated best use, as we have discussed earlier. According to this, we have told you that out of several uses a particular water body is put to, the use that demands highest quality of water is called the designated best use, and accordingly the water body is designated. The CPCB has further identified 5 such designated best uses for water and has set down various criteria for the same, as we have discussed and told you earlier. So students, after having said all that, I hope you found this module very informative regarding the water quality standards and the various criteria set for use of water bodies in different manners.